Now we are recorded, so again, let me invite you and say thank you for joining me during the Programming Technologies Lecture 12. Today we are going to discuss the graphical data. So the first question for you is, of course, what is graphical data? Next, the agenda for today, it is XAML as a language. Additionally, it is also the technology. Today I said that language integrated query is not technology, it's part of the language. It's true, but to use it, we need external technology. So the language is expandable by the external technology, and if without this technology, we can use only a limited functionality of this language. Language integrated query is part of the language semantics and syntax of that it's embedded in the C#. But XAML, it is also the language, but it's not embedded inside the C#, so it's not part of the C# language. It is completely independent language, but still we need to know relationship between this language and the basic language we are using for programming C#. What is relationship, and how to explain all the features the XAML provides. Next, we'll discuss about MVVM. MVVM is a model view model. It's a pattern, it's layered pattern. About the layers we discuss a lot, but now we'll concentrate on the selected part of the program where we have when we must deal with the graphical user interface, where we are building graphical user interface, where we are designing graphical user interface. To solve the problem, selected solvent related to the MVVM, we need to use delegates and events. Actually, I spent a lot of time discussing delegates and events. So now I'm going only to recall some basic feature of this two language terms, language constructs. Okay, so let me get back to the very beginning, where we have a program. Program is executed, so at design time is a program, a set of files. Set of each file is a text file. Let me also recall that the stream of bits becomes text after definition of the encoding. So if the file is a text, it must have associated encoding. Not all the files we are using to design to provide program to author program. Some files are binary files, so they don't have any encodings, cannot be exposed as a text on the screen, for example, but not only. But in all of the cases are created by appropriate designers, by appropriate tools that are embedded in the design, in the development. Or therefore, directly we are not using these files. For R, the program contains only text. It contains only too long answers to my simple question. We don't have time to waste. Therefore, let me ask you next question. Maybe it'll be easier for you. Is it possible to process directly information using computers? So if we can use computers to directly process information, it is the idea of the question. But do you remember that, let me recall that program is a text. But in the program, in the design of the program, we can distinguish layers. Because the program is a text, it must be, we must provide additional definition how to create layers from the text. Usually the text is must be, it is not our option, it must be, if the text is correct, it must be formatted according to the syntax rules, Syntax rules provides all we need to concatenate all the characters belonging to the selected alphabet. Alphabet is defined by the encoding. So depending on the encoding, we can use different alphabets. Usually, at least we are assuming that the encoding is ASCII and the alphabet is defined by this encoding type. Using this syntax rule, we are designing a language construct, and assigning to this language construct appropriate meaning. And one very important construct for us is type. So the layers, it is just aggregation of the selected types. Let me recall that types we are using to provide appropriate functionality. Therefore, we are grouping the types and actually creating appropriate layers on the base of selected functionality. In program, we can distinguish three layers. Usually, we can distinguish three layers. Presentation, that is responsible to expose the data, to provide communication with the user, or with, for example, also network, because the network sometimes is used to interconnect with other programs, combining together, creating together one application. Logic, this next layer, this layer is responsible to provide all the functionality related to the program. Presentation provide data and functionality related to the user interface. Let me narrow this functionality and let me discuss only this functionality. Forget about communication over the network. Presentation will use only during this faculty, during these classes, we'll use only for communication with the users. Next question for you: what is data streams? What is data streams? Okay, data, it's responsible to provide what we discussed previously, data. So it is representation of the information. Representation of the information. Information is abstract. Therefore, as you answered correctly, no, computer cannot be used directly to process the information because the information is abstract, and the computer is a device, so it's impossible to use devices to process any abstraction. Therefore, we must represent the information as a data using many different coding systems. And depending on the coding systems, the same information could be represented in a different ways. But for us today, the most important thing, it is the layer presentation and graphical user interface interconnected. and controlled by the presentation. So presentation is responsible to control graphical user interface. We are assuming the graphical user interface, it is external device, for example, monitor, that we are using to provide interaction with the user. Additionally, we are using, for example, keyboards and other devices as entry devices that we are using to enter new data. Always it's data, and depending on the language you are using, the data could represent different. The same data could represent many different informations. Additionally, in the program, we have also data streams. Data streams actually are realized by operating system as a stream, as a files. So the data stream, it is actually the bit stream. Bit stream, that it's part of the file. That to be useful, this bit stream must be described by metadata, and this metadata together with the data creates files. And we are using a modern operating system. We are using a file system to manage all the stream data. Next question for you: what is language? Because I am using these terms. I used these terms many times, so let me recall what it is. Next, it's structured data. Structured data additionally means that we have complex data, and the data, part of the data, the entities of the data are interconnected by references, so create something like graph. And using this graph, we can define a relationship between the nodes, between the entities, and finally the graph we can use freely to expose any structure. Therefore, sometimes we call the structured data doesn't have any structure, or it could be, for example, full mesh, but we are using references, interconnection between the entities, usually complex entities we are using to create any structure. So let me summarize. Let me conclude this part. So let me ask, what techniques are used to manage streaming, structure, and graphical external data? External data, graphical data, it's still the information that is represented, but it is represented by graphics. So it is a representation that resembles, can be recognized as a native language. Usually we are using selected part of the native language to build the graphical interface with the user, to make sure that the user and the computer interconnects using the native language for the user. Therefore, graphical language. Of course, it's difficult to share. For example, graphics is to send graphics and things like that. Therefore, at the end of the day, under the cover, usually we are using stream of bits, and we are using structured data, and this streams and this structured data is converted to the graphics. It's converted to the graphics, and this conversion we call rendering. And today we learn more about rendering, how to render data on the screen to construct appropriate appropriate graphics. Next question, it's I think should be asked at the very beginning. What layer should be selected as a starting point of the program bootstrap? Program bootstrap means that we are starting the program. So the starting the program, we must load the program into the memory, random access memory, and usually operating system is responsible to do it. After that, the operating system must transfer the control of the computer, control of the processor to the program. So it must select just one single statement in the program, instruction, that will be executed as a starting point. So where it is located? The question is where it is located, but let me answer to the previous question, what technologies we are using for streaming. Of course, serialization, for structural data, language integrated query. We discussed about it today morning. Language integrated query, it is a part of the language that's dedicated to manage, actually to fetch the data from the databases. Graphical data, to manage graphical data, we are using technologies, and we are using built-in features of the environment. For example, Xaml, it is an example that we can use, that we might use to organize the graphic. Of course, it's not the only techniques. We have many more techniques, many more possibilities. Usually, today I will provide all the examples using WPF, Windows Presentation Foundation. It is technology that is coupled together with the language. So the language of the environment provides some features that can be used, and it's the most important for us. What next? So what layer? The highest layer, the presentation layer. Okay, let me stop. I'm waiting for the last. Stop the discussion. Okay, stop the discussion. Yes, you are right. It must be the top layer, because only the top layer could create objects from the types from the layer above. Having layered application, we must start from the top layer, because only the top layer could get access to the layer below, and the layer below could get access to the layer on the bottom. Therefore, everything must start from the top. Sometimes we call these techniques as top-down approach. So we are starting from the top layer. It also applies to the design of the program, not only to the starting of the program. Therefore, if we are starting to design the program, sometimes it's very useful to try to design interface with the user and agree with the user the functionality of this, not only functionality of the graphical user interface, but also, for example, colors on the screen, because sometimes colors makes problem. Selection of the color, it's one very simple and very selected part, and I wanted to demonstrate it, but to do it I must to switch my screen. So let me stop sharing for now, and next share another screen. Hopefully you can see the screen. Now I must move everything on my second screen. This one must be over here. This screen must be over here. And there's another Not this one, this one. Questions. You can see I have a question, questions for you, next questions. So before I will start discussing using an examples, let me ask you the question, MVVM, where it comes from? Name of the technology it was used as a foundation. Where the MVVM was born. Here you can see on the screen. Now, let me stress that now we will talk about the external data management. So it is inside of the TP repository on the GitHub, and there is a folder, last folder, because we are approaching the end of the semester. So let me recall that it is last time to provide all the solutions and to get all the grades. We will talk about the graphical data in separate folder, and here we can find three projects. First project we call graphical data view, and second project is graphical data, and this project provides two folders, model and view model. As you can see, MVVM, maybe I can ask the next question. Very simple. I hope you are still writing, but I am expecting only a simple words from you. MVVM, what it stands for? What is the meaning of the MVVM? Let's try to provide explanation in a few words what it is. But we can see that MVVM is, as I said previously, is a pattern. So if it's a pattern, it's layered pattern. From this example, we can learn that MVVM was implemented as three independent parts. First is the project, graphical data. It is view layer, referring to what it means. Let me ask next questions. Maybe it could be more complicated. What operation must be supported by the graphical user interface? 3 words. I'm expecting just 3 words. What happens on the screen? What happens between the screen, between the computer and the user that sits in front of the computer, that controls the computer? So MVVM is a layered pattern. So we need 3 layers: layer view model, and layer model. Here, the layers were implemented using the project, graphical data view. It is the project. So actually, the layers are implemented using, as usual, the namespaces. One namespace it's related to is provided by the graphical data view project. It's independent project, but view model and model is provided, is defined in a graphical data project in this project. And next project we have, it's unit test. And so here it is the first information. I haven't asked it, but so let me explain that MVVM first, of course, was born by the WPF, Windows Presentation Foundation. It is something that is embedded as a pattern, as a concept inside WPM. Of course, it is a useful pattern not only in this context, but in many other contexts it could be also used. It's still layered pattern, and the question is why? What is the reason we need it? In the meantime, let me ask you the last question for this part of the lecture. What types should be aggregated by the view layer? Let me get back to the previous thoughts that I said that actually this layers implementation of these layers refers to the namespaces. Are using namespaces. So namespace is a container of types. It is a set of types. It contains all the types that is related to the layer. So presentation view, it is located in the independent project. ViewModel and model additionally have folders, but as a result of using folders, new namespaces are created. So as a homework, you can check that view refers to the ViewModel and ViewModel refers only to the model. And model doesn't refer to the layer below because it's independent example, just an example of the presentation layer. So these three layers, view, ViewModel, and model, must be located, in all of the cases, must be located in the presentation layer, and model, let me start from the bottom explanation. What type should be gathered should be added to the set of the types in one layer. Model is responsible to provide data to be exposed on the screen. It contains only this data that is on the screen. It should be not recognized as a layer responsible to provide the data for the application itself. Here, this example contains only an example of the presentation layer. ViewModel, it is next layer above the model and get access to the model, only to the model, and is responsible and should collect all the types that are related to the functionality of the graphical user interface. So here we should expect all the types providing functionality of the screen. Let me recall that we need to handle three events through three different. So answering the question, what operation must be supported by the graphical user interface? First, it is displaying on the screen. So display the data on the screen, rendering the data. Usually it could be a picture, or it could be text. It could be something that it's aggregation of the pictures and the text together. You can see, for example, here on the screen, on the upper window, it's the design window, and in this design panel, we can observe a graphics and pictures, but still part of this graphics has some functionality. Second operation we are expecting from the graphical user interface. Let me stop the discussion. What type should be? Stop discussion. So next operation we are expecting that happens using the screen and the keyboard is entering the data. For example, here it is a text box that we are using to enter the data. After running the application and starting the application, here we should get possibility to enter the data. Of course, here we must also remember about next functionality, that it's under the cover. It is not related to the screen and to any operation of the user, but must be provided by the view model or by the view. It is data validation. Usually, we must limit the data depending on the information we are going to represent on the screen. If it's number, we should provide rules about the number syntax. If it's text, we must, for example, limit the length of the text. We must check the, we must provide a spell checker that help us to avoid any mistakes on the screen. Additionally, if there is, for example, the data that represents very special information, like, for example, age, it must be a number, but depending how we are going to represent the age, for example, it could be cardinal. It must be above 0 and must be it must not be any fractional, any real, any float. It must be cardinal, all positive unsigned integer, in other words. So validation, but validation it's coupled together, must be coupled together, must be provided as a functionality that is related to entering new data to the application. And third and last operation that happens on the screen is just comments. So we can use buttons, and we can use links that are clickable. So we can click on the screen, we can use the mouse to click on the screen and provide comments. Let me start this application to show you all these operations. It takes a while, but we should expect on the screen similar result. Now it is graphical user interface from the real application. It's not a picture on the designer. So for example, here in this window or in these two windows, we can expose the data. Clicking on this button, you can see that data is exposed on the screen, is rendered on the screen. So we can command the program to expose the selected data. In this case, we've got very simple data that, for example, could came from the database. Additionally, we can provide the data. Here you can see that this text, I can provide any possible text, and using this button, I can render the screen as independent window on the screen. Additionally, there is next button that opens a pop-up window. This pop-up window, it's independent window that have additional functionality, and this functionality, for example, could be used to provide additional information, additional data. Depending on the kind of the data, we can use many different techniques and different controls. Usually on the screen we are exposing controls. Control has graphical representation, could be exposed on the screen and provide some functionality. This functionality is related to the interface with the user, but can also be, we as the programmer should be aware about this functionality, but because this functionality we must handle somehow. Depending on the functionality, for example, if it's button, we must handle the event that we must do something, that must be executed functionality. For example, popping up additional window. If it's a text box, we must be ready to get the entry text provided by the user. But our lesson is not about how to build user interface. It depends on the technology. Therefore, let me skip it, because we must learn about the programming, about the general rules that can be applicable to almost all the technology, almost all the techniques. One of the very important thing we have, for example, here, we can see that on the bottom, maybe I can enlarge it, we can see something like this. It looks, because it's text, still it's text, we are dealing with characters, but it looks completely irrelevant for the C#. So it is not similar. There's not resemblance between, but there is no similarity between the text we have in the C# and here. So my next question is it programming language? Is it programming language? Check the chat window over here. Is Xaml a programming language? So on this screen we can see programming language. It is one very important for us thing. You can see that we have two windows, and two windows are coupled together by the designer. So any modification in one window will change the second window, but forget about it. It is for your homework how to design a very simple user interface. But for us, is the most important question is why we need additional. Yes, because answering to the previous question, yes, it is the language. It is the language. Let's stop the discussion, asking the next, what is XAML? And as you can see, it is the language, but the file looks like XML, expandable markup language. So it is very important if XAML it is an additional language, because the text looks like XML. It looks exactly like XML, and actually it is XML. Therefore, my next question is, what is the difference between XAML and XML? No idea? To the previous question, what XML and XAML has in common? It was the previous question. Now, what is the difference between? What difference between? As I said previously, XAML is based on XML. So actually, we are using XML for XAML, and this file, it is just the document, XML document. So everything that happens here is according to the syntax rule we have in the XML. But the problem with the XML and with the XAML is that XML doesn't provide for us useful semantics, so meaning, because in XML here just element, it is just attribute. And what means this attribute? What means this element name? We don't know. We cannot learn from the XML how to, for example, how to create this document, what is possible, what not, what is wrong, what is correct. Why, for example, data context window.data context, it is correct or it is not, because it looks like embedded element inside the window. So last question related to this topic, it is why XAML is based on XML? Answering this question, you are answering this question, why? I try to tell you a story. A couple of years ago, we tried to present an application that we was very proud about. It is a lot of work. There is a big team working on this application, and our colleagues from US. It is also a team of users of this application, and all the people in the team were very happy, except one girl that said, "Okay, the application is pretty good. It's good. Actually, it is everything provides what we expected, except the colors, because the color here is not American colors." Therefore, the question was how to define what is American color or not. Of course, there is many possibilities. One of the possibilities to create a picture using for example, Paint, or using the PowerPoint or something like that, and provide the picture to the programmers, and the programmers could convert this picture and design something like we have on the screen now. But still, there is a lot of difference that could be. It's very hard, for example, to follow any instruction provided as a graphics, or provided as a additional description. Therefore, there's an idea to use something like that. So let's stop the discussion. Stop it now, because now I'm going to answer the question. Here we have this XAML file. XAML, it means that it's in XAML language, provides XAML text, and the design panel, design window we are using. But we can open the XAML in a blend, design in a blend. It takes a while. It is completely independent application. It looks like Visual Studio, but it's not Visual Studio. It is application. It is actually the designer. It is the application that we can use to design a graphical user interface only, without any functionality. Forget about writing a program, but still we can see, for example, here that we have a designer, we have XAML, things like that. So let's wait, because the designer still is loading. You can see that we have very similar picture, but the environment is slightly different. And on the right side, you can open it from the view menu. It is a property window. Here we have property window. Let me pin it. And after selecting of the selected part of the screen, I can get on the right side many options. For example, I can get an option to select the American color. I can say that, okay, it is American color, it is American blue. If it is wrong, I can move it from place to place. You can see this way we don't need any programming skills. We need only to know how to use an additional editor, additional additional software to design the shape and to design all the details. There's many options. All of the options are not related to the programming, are related only to the designing of the picture. So after closing this, let me save it file, save it and close it. Now we are back in the Visual Studio. You can see we are getting, there's popping up a new window that asks about modification. So something happens in the background. You can see that now we can get the same color. We can save the same color selected by this US girl. Instead of trying to explain how to design the screen, how to design the graphics, how to design the picture on the screen, how to re-render any information, it's enough to provide this main window XAML file to our friends, to our customer, to our to the graphical designers, and say, okay, you can do what you like, and you can select your colors, you can select your shapes, you can select everything what you like on the what you like on the screen. Additionally, we can provide some functionality that happens on the screen, because screen usually is stateful. For example, providing an information, it happens that it's possible to enter some commands and additional commands related to this information. Without this step, it could be impossible. Therefore, we are talking about the history of the screen, and we are talking about the state, that the window, the graphical user interface could change from the state to state depending on the data it's provided. So why it is in XML? It is in XML because it's data. It's data for the additional, for the another program. Because the XML is a perfect it's a perfect representation of the information that can be provided as a data, as a file from another application. It was selected. It was selected because syntax in this file is well defined by the W3C corporation, by the organization, standardization organization. Therefore, we have a document describing all the syntax rules. But what is the difference between XAML and XML? The syntax is exactly the same. It is XML file. It must be XML file. So the characters are the same. So alphabet is the same. The syntax is the same. The only difference we have is semantics. It's meaning of this type. For example, it's meaning. What the window mean? What did the grid mean? Here's just the word. But we must know what it means, but in terms of the language, not in general. I think that the best way to answer this question, what, for example, the grid means, is to use F12. Because F12, so go to definition, I press F12, go to definition, you can see that it's class. So the meaning of this word, in terms of the XML, it means element. In terms of the XAML, it means that it is something related to the class, related to the type. This type is provided by the presentation framework. Therefore, XAML, it is embedded part of the program. We are using it as a program. So it is language that we are using to design a part of the program, but it refers to the type we have in the external. In the library here is not external, it's basic, is one of the basic library, but still we can recognize this library as external library. Why? Because it is related to technology, to the selected technology. Presentation framework makes sense only and only in context of the Windows, in context of this platform. If we are using different operating system, it doesn't make sense, this presentation framework, because this framework is responsible to re-render the data on the screen. So controls in this. So what is the control? The control, of course, is a class. It is a class that inherits from some basic classes that can be used by the running environment to render pictures, to render graphics on the screen. It's possible only if you are using a selected operating system. If you are using different operating system, we must provide different library. The library that is dedicated for this operating system. So it's possible to port. It's possible that your program will be portable, but definitely the presentation layer must be replaced. Therefore, we must use layers to replace only one presentation, or rather, in this case, only the view supplier, instead of rewriting or redesigning the whole application. Okay, it is one reason. So it is the question about reusability. Usually, it is assumed that the XAML is reusable. So actually, implementation of this language could be provided for many different applications, for many different operating systems. But still, there must be provided implementation. It's like with the language integrated query. Let me get back to this example. Language integrated query, it is part of the language. It is embedded in the language in C#. Here, XAML is not embedded. At the now we cannot find any similarity with the language, but language integrated query has similarity, and actually for this construct appropriate semantics rule are provided by the language. But in case of the language integrated query, to provide to use this construct, to use this part of the language, we can implement iQueryable. Implementation of the iQueryable, it is a common point between your program and between the external requirements of the external data sources. If it's a SQL database, Microsoft SQL database, you can select a library that provides implementation of the iQueryable interface for this environment, for this SQL database. If it's Oracle database, you must have implementation of the iQueryable for this environment. If you don't have any implementation or iQueryable, you still can use the database, you still can fetch the database, you still can modify the database, but it's impossible to use language integrated query. It is required for the language integrated query to have implementation of the iQueryable. Here, for the XAML, we have exactly the same. We are referring to the types, and these types are implemented by the framework, and this framework is dedicated for the selected environment, for the selected platform. So we must have all the files, window, grid, and for example, list box. Let's check it. List box is also a type. It also refers to the type. It's not type, but it refers to the type. Definition of the types we have here. But in XAML, we are referring to this type. So all the types that are provided by this, are used by the XAML, must be implemented in a appropriate library, in the appropriate framework. Therefore, we call it technology. Now we can call it technology. It's technology like in case of the language integrated query, where we can talk about the technology as the implementation of the iQueryable. Here we must talk about the we might talk about the technology as implementation of the all types that are required by the XAML. So what kind of types we are talking about? We are talking about types that could be rendered on the screen. For example, this grid, selecting of this grid, we can see that the designer select almost the whole window, because the window is responsible to implement, but maybe selecting something inside, for example, this list box. Let's see what happens on the screen. You can see that now the list box is inside. It's not this the whole window. But anyway, so all the types we are using in the view layer are rendered. Sometimes we are using additional classes, additional types that we are defining, for example, for the validation. Of course, take care about defining your types as a part of view. So embedding your types as a view, because usually this classes doesn't have any rendering functionality, so cannot be exposed on the screen. So the only reason to put these types as a part of the view is that they must refer to some types that we have in presentation framework. Additionally, let's look at the structure of the program. I said that the graphical data view is a view. So actually, it implements view layer. Properties provides details about the technology we are using. You can see that now I'm using .NET Framework. I must use the .NET Framework or any technologies related to that has appropriate implementation of the Windows, because the framework I'm using must be aware about the platform that is executed on. Additionally, let me get back to the question where we are starting. Where is the point of the starting? Here it is startup object. Maybe to enlarge, it's possible to enlarge it and still make the screen clickable. Startup object, here you can select startup object and it goes view application, like application. So let's go to this class. This class we can recognize, for example, here. But still we can see it's XAML. It's XAML. And this XAML is coupled together with another class that has suffix CS as C#. And we can see it's C#. And actually it is created by XAML and XAML C#. Both are created by the designer. So after creating WPF project, we are getting these two files created by this designer. But both files are coupled together. On the right side, you can see that both classes we have coupled together. So it says that there must be a relationship between XAML and C#. There might be a relationship. For us here now, it is the most important question is how to distinguish and how to describe this relationship. Again, let me organize the screen this way that we have both files on the screen. On the left side, we have XAML file, and on the right side, we have C#. You can see that here the class calls app, and it inherits from application. On the right side, we have also this app, but as a prefix there is a namespace. So here we can distinguish we can distinguish the full name of the class. We can distinguish full name of the class. So this public partial means that maybe this class is a partial class of the application. In general, it doesn't make sense because partial means that, of course, it's possible to define the same time using different places, different files. But compiler is responsible to merge these files to create one file that is compiled by this, that is built, that takes part in build process, and after that code is generated by this compiler. The executable code is generated by this by the compiler. Here it's impossible because having two different syntax is impossible to merge text. After merging the text, full measure will be the result. So we must assume that selected part must be harmonized with the another part. And because we are talking about C#, we can assume that this application, this XAML file, is converted. Actually, it is translated to the sharp, because everything here also is refers to the C#. For example, application, as you can see, is a class, is a special class. And environment, as you can see from, there is a property window here, you can see that the environment knows all possibilities. It is drop down, but still there is only one option, because in the program we have only the one class that inherits from the application. Here we can expect all the classes that inherits from the application class, and selected one will be used by the environment as the entry point. So where is the entry point? The entry point, of course, it is the first instruction here in a constructor. So actually the application, the app class is instantiated, but do nothing. If it does nothing, how to prove that we are starting the application? The answer we can find here in the XAML part. What is startup URI? F12 answers this question. It is just a property. It is property of the application class. So it must be recognized as the property, as assigning to the property something. What we can assign to the property? Of course, we can assign to the property only the present, only the reference. The property is URI, so it is a next class. Therefore, we can describe this line as creation of the object when main window. So the main window is created, and the reference to the main window is assigned to the startup URI. Next statement, expected to be executed. Of course, it must be constructor of the main window. Main window we have here, and in main window, in the constructor, there is initialize component. This statement says call a method, call initialize component methods, but the methods, there is an error. Actually, the error says that this method doesn't exist. Trying to use F12 here, let's select it and use F12, we are getting a pop-up message that cannot navigate to the symbol under the caret because the initialized component doesn't exist. But it must exist because we can run this application. It's possible to execute this application. Therefore, it must be here, but we cannot. It's impossible to navigate to this method. The only answer to this question is that the method is auto-generated. It's auto-generated, and now it doesn't exist. It will be generated. It will be generated during the execution. So while starting the application, after starting the application, the environment will create this method, and this method must refer to the XAML part of this the same class, because it is partial class. It is also partial class. Here we are referring to the main window full name as in the app class. So we can assume that here we are referring to the class main window. And this class inherits from the window. To prove it, we can open this, and we can see that really main window inherits from the window. So XAML must be converted. Somehow must be converted, must be translated, converted, done something that at the end of the day will create auto-generated partial class, and this class is in the C#, will be merged with the main window, with this part, and together we'll create class, final class. So let's try, if it's C#, therefore everything what we have in the XAML must be, it must be possible to explain everything here in terms of the language, in terms of the C#. For example, grid. F12 says that it's class, but additionally it says also that it could be constructor. If it's constructor, it makes sense to interpret this, to provide meaning to this line, that we are referring to the constructor. So we are instantiating only object to make sure that the object is still alive, so will not be destroyed by the garbage collector. We must assign this reference somewhere to the selected placeholder, to selected variable. It could be, for example, collection. So we must add reference to this object, to the collection, to make sure that the object not disappears in a second. Because it's rendered, it could be possible to render this object. This reference says to the environment, is used to the environment to render grid on the screen. Therefore, if you are asking what the grid is, usually I'm getting the answer, it is something on the screen. No, it's not true. Grid is just a type, and here we are referring to the constructor in terms of the language. Because the type could be rendered on the screen, we can get picture on the screen for this type. Therefore, finally, it could be represented as a picture on the screen, but it's a side effect of the type. It is special type, and that is coupled together with the technology. Very important is what next, because after calling this constructor, we are calling initialize components. Of course, let's assume that it's auto-generated and it appears during the runtime. Okay, it appears during the runtime, but still, we must expect that this layer, view layer, will create the layer below. We'll create ViewModel layer. ViewModel layer, should not be dependent on the technology. Therefore, it should collect all the classes that are coupled together with the functionality of the screen. But functionality of the screen must not depend on any technology. It is universal. Information could happen on any kind of the screens. Therefore, providing 3 layers from the presentation layer, we can, at the end of the day, we can obtain functionality that, sorry for that pop-up, but I have next lesson, but still I have a couple of minutes to finish what we are talking about. So the next, we should expect any statement that refers to the layer below. Let me stress the layer below is somewhere over here in the view model. Of course, we should expect that main view model, it is a class that should be created next. Let's try to find this name. Control C, and where is XAML here? Control F. You can see that it happens that in this line we are referring to this name. VM, it's a namespace. From the XML, we can learn that it is shortcut. It is the name that we can use to replace this this long string. Instead of this long string, we can use a replacement. We can use these two letters as a shortcut over here. So this line we can guess that first part refers to the assemble and says, okay, this type is in this assemble. And next we have TP graphical data. It is the namespace. It is the namespace that we can find in this. We can find in this assemble. It is because XAML, it is XML. XML is based on the XML language, but XML doesn't use something like references or dependencies we have in Visual Studio. So references, relationship between the project in Visual Studio, we can express using the references and dependencies. But in XML, it is impossible. Therefore, we are using something like this. But still, it's correct. The syntax is according to the XML, but semantics is according to XAML, because we know from XAML that it is assemble and it is the namespace inside of the assemble. But okay, what happens here? Can we go to the definition? Let me F12. Cannot navigate here. Maybe there is something wrong with the code, but it is this class. I tried to compile it again. Opening everything together with the blend, it makes that sometimes the designer have problems to find appropriate definition to get between the types. Now it's possible. Go to definition and cannot navigate. Still it cannot navigate. What happened? Doesn't matter. So it is this class that is located in the ViewModel. But what is data context? Maybe the data context, it's easier to find. Data context, you can see it is property. It is property located in the framework element. We can guess that the framework element is on the inheritance chain starting from the window, somewhere over there. Therefore, here we can, these three lines we can explain as the instruction, as a statement, as a assignment statement where we are assigning to the data context, we are assigning new instance of the main view model. This way, we are using XML to provide a different implementation of the assignment instruction. Data context get new value, and the value is reference to new created object. Therefore, this view layer, we can say that this view layer refers to the layer below because it creates here at the very beginning where we are calling this this class we are calling initialize component. So we are calling this part. We are creating all these objects. Additionally, main view. In here, main view model is assigned to the data context, but where grid is assigned. So still we can recognize this line as a statement. It could be a sign statement, but it could be also the call method statement where we are adding a grid as an entity to a collection. But the collector is a window. Therefore, this hierarchy that we are using in the XML can be used also to assign, to find all the collectors and all the types that are collected, that all the instances that are collected by this type. So it's XAML. I think that's all we can say about the XAML. The next will be bindings, but let me answer to the last question. What is the reason that we are using architecture like this? There is a very simple question. So we are using XML because the XAML should be processed independently on the solution by independent application, by the users, by the designers that don't care about the programming language. They care about the graphical user interface, but they care about what happens on the screen, how to organize the screen, how to design the screen, but not with the functionality. But the layering we have here, it is implementation of the separation of concerns rules. We are trying to narrow view to provide only the functionality that is related to the graphical user interface, nothing else, nothing additional, because we need to think about unit tests. Here you can find the project that provide unit tests for this example, and this unit tests are dedicated to test only the code that is not dependent on the technology. Especially, it's not dependent on the graphical user interface. The graphical user interface requires appropriate operating system, but unit test must be executed in the environment where we don't have any user interface. If we don't have any user interface, we must check only the functionality, but not the graphical representation. Therefore, for the graphical representation, we are using different kind of types. It is out of scope of these classes to learn about these tools, but let me stress that in here it is very easy to define unit tests only for the layer below, for the view model and for the model. Therefore, graphical, to make sure that we have layered application and that we are not referring in the view model to the types that are related to the view, that are gathered by the view, because they come from the different DLL. You know that presentation framework. Presentation framework provides all the types that may be rendered on the screen, but we must avoid to get access to this type to make sure that everything in ViewModel and model is testable using the unit test. Therefore, ViewModel and model is implemented using the standard technology, .NET Standard. .NET Standard means that it is abstracted from the technology. It is not possible, and it is the role of the environment to check that everything that we are dependent on, it is not related to any technology. Therefore, for example, here, it is not possible to add to the dependencies any frameworks that its implementation on any technology that is related to any technology. .NET Standard is an abstract definition, and implementation is assigned at the runtime. After starting the application, appropriate environment is added, is linked to our program, and it must not be any dependencies on the technology. Okay, it is very important for you and for task to not provide any links, any dependencies in a model or view model that relates to the presentation framework. That's all for today. I think, let me now switch off the recording.